Okay. I didn't think I was doing graphing E till this class, but evidently it was on the bottom of your worksheet. So we're going to talk real quick about how do you graph E. We actually know it from the past. Well, let me ask you this. How did you graph 2 to the x? To find some points to plot, you had to do, on 2 you could actually do up to 3. 2 to the 0 was 1, 2 to the first was 2, 2 to the second was 4, 2 to the cube was 8. We plotted those points. Okay? So if you want points to plot for E, what do you have to do? Use your calculator. You only need to do 0, 1, and 2. After that, it gets too big. But you're actually going to have to go, what's E to the 0, E to the first, and E to the second. Yeah, 1, 2.7, because we know E to the first rough value is 2.7, and then you simply need to square it, which comes out about, rounded off, about 7.4. And you just have to know those values to do E.
This is the most, right?
Yes. So it's going to look the exact same thing as an exponential function, because remember, E is nothing more than the base number, 2.718, going forever. So all we're doing is taking it to a power. So where's the asymptote going to be? It's still going to be an asymptote down the x-axis. It's going to look like every other exponential function. You're just going to plot 0, 1, 1 over, and 2.7 up. 3, 4, 5, 6, 7.4. Yes, E shoots up fairly fast. And so it's just exact same thing, exponential function. It flips identically to the same way all the other ones flip. Everything's the same. Don't let E bug you. It's just that you have to know those couple decimal values to plot E. But otherwise, it's exactly the same as every other exponential function. We're actually going to discover once we start putting logs with it, you may recall there's actually some things that are easier with E than they are with regular numbers.
Yeah.
Okay. So that's E. We're going to come back and do more with E today. Don't worry. E's not going away by any stretch of the imagination.
By any stretch, Luke.
But today, yes, it's the ultimate topic.
Log.
Technically logarithms, but more affectionately known as simply logs. And hopefully this year you will develop a more friendly, loving relationship with your logarithms. Yes, thank you. Logs are great. Logs do some amazing things for us.
My sister said you'll never use any math that you'll ever learn. Ever. This kid, Miss Math.
I don't think. I was going to go, I can't believe your sister said that. Because I'm pretty sure she's experienced it different. Okay, this is exponential. What did I tell you was the limits on what kind of numbers the base can be?
Positive.
Had to be positive, and it couldn't be?
1 or 0.
Could be 1. It also can't be 0 either. It can't be negative. Okay, consequently then, what kind of numbers could x be? And x could be any real number. What kind of numbers was y going to turn out to be? Because the base is positive. If you take a positive number to a power, you get a positive number. So yes, y will always turn out positive as well. That's fact. Okay. We want to make logarithms. Then you better remember how you get a logarithm out of an exponential function.
By logarithm. ln. ln. Log and plug. Inverse. Log it.
Logs are the inverses of exponential functions.
That's what I said.
Caleb, This is all on the recording. Okay, so if you're doing the inverse, what were the 2 steps to finding an inverse? How do you find an inverse? You switch x and y, and you solve for y, okay? So if you take this original equation we have here, and you switch x and y, I'm going to have x equals b to the y power, but then they hit a snag. How do you solve for y when it's an exponent? Okay. Well, then they had to come up with some math to explain how could you solve for an exponent, and also then they had to prove all of this to be true. That was kind of important. So we actually, yes, found out that when you went to solve for y, if we're going to solve for y, to solve for y, they said, hey, we're going to call it a logarithm. And you have to keep track, though. Y is the exponent, but you have to know what the base was originally. Where did they put the base? It's the little, base b on your log. It's the subscript. Log base b of x, yes. And so x is the same number. Yes, it stays the same number. So let me put that in perspective for you here. Would you all, let's not do 2, we've been doing lots of 2s. Would you agree that 5 cubed equals 125? Okay? If I said write that as a logarithm. Log 5, 3. Log of 125. Log. Base 5. Okay, so the big question is it a log of 3 or log of 125 equals 3? Yes. Yes, you're solving for the exponent. A logarithm is representing an exponent. So you're solving for the exponent whenever you do a log. So notice, when you look at the log, it's 5 to the what power makes 125? 5 to the third makes 125. Yes, ma'am. We're going to come back and do a whole bunch more of that in a second. But that's where you're going when you go with a logarithm. Yeah, so if I gave you, let me give you a couple easy ones. If I gave you log base 7 of 49, I'm saying what power, 7 to what power? 7 to what power is 49? 7 squared, yeah. Okay, and let me point out that you can, if you rewrote the 49 as 7 squared, when you have the same bases, then the answer is simply the exponent. So 7 to the second power makes 49. So if I gave you something horrendously horrible like log of 1,387 of 1,387 to the 11th power, what would the answer be? Yeah. If your log has a base 11 and your exponent has a base of, if your log has a base 1,387 and we have a same base here, yes, the answer is just 11. As long as they have the same base. Logs are inverses of exponential functions, so logs cancel out. Logs cancel out inverse expressions. Your answer is always an exponent. Logs solve for exponents. Will we ever have to? How would you solve a log without a calculator?
There's a way. And
yes, there is. It's horrible, but there's a way. Log base. So you're saying 5 to what power? Yeah, the answer is what the exponent would be. The power? All I did is I rewrote this. This is called exponential form. And this is called logarithmic form. represent the same thing. You're writing the same exact thing in two different ways. You can write it as an exponent, or you can write it as a logarithm. It's the same thing that you just switch how you write it. Well, if I'm just saying rewrite it in a new form, you need to write it off. But here I was actually asking you to figure out what would this equal. 7 to what power makes 49? 7 to the second power makes 49. And we're, like I said, we're coming back and doing a whole bunch of those in a little bit. But
How do you find it without a calculator?
well, if you can make it have the same bases, you can find it. If you can't make it have the same base, then you can't find it without a calculator, or you have to have a table of values and learn how to change it to exponential form, add logs, and look up all this stuff. It's horrible.
Oh, we don't do that?
No, we aren't. It's the way I had to do it back in high school, but you don't have to do it that way.
Someday we will think of how awful it is right now, what we are doing.
Probably 1979, 80? 80? Yeah. I got, for my high school graduation, my sister, the math teacher, gave me, oh, this is still clicking, Booker. When you see a log, it represents an exponent. That's absolutely crucial that you get that concept.
You guys hear an echo also? I'm going to drink some. Why banana?
Because it shows up on the background.
Yeah.
Okay. That's key. Right there. Logs represent exponents. Okay, now I need to make a couple connections for you here between what we just did, but I ran myself out of space. This is what we had just decided moments ago. If you're an exponential form, the base had to be positive and it couldn't be 1. You told me x could be any number, and you told me y could only be positive. Okay, if you change that to logarithmic form, if you rewrite that as a logarithm is going to solve for which variable? Solve, what does it represent? An exponent. A log solves for an exponent. So you're going to say, oh, I know then that x equals a log with what base?
Any base.
B base. And so therefore it has to be the log of y. Technically that thing inside the log is called the argument. If you want a name for it, it's the argument of the logarithm. So what I want you to notice is what happened here. If my base before had to be positive, on a log, your base still has to be positive, and it can't be 1. These rules still apply. Okay, but x can still be a real number, so it means a logarithm can come out equal to any number you want. But what do you know about the number inside the log? Y. That's got to be positive, greater than 0. The easy way to remember it, everything attached to the log, the base and the argument, are always positive. You cannot have anything attached to a log that's negative. Everything attached to the log must be a positive number.
In other words, nothing really changed.
Yeah. This is the same form. You can write an expression as an exponent or a logarithm. You can switch back and forth. It's just a matter of what form you're in. Yes, Colin.
Journal, please put all that stuff for number 8 because relationship.
I have no the relationship, yes, is that. Yes. Okay, but what I want you to notice, excuse me over there. Okay, here, x is inside the function. So that would be the domain, would it not? And y is the range. But now, when I've switched, y is inside the logarithm, so that makes it the domain, and the range is what you're equal to. So your domain and your range have switched places when you go between exponents and logarithms.
Ah, that's the difference.
Okay.
Okay.
So you've switched. Thank you, I'm at 15. Okay.